Hi students, welcome back. Coming to the next topic in the computer graphics is the 2D transformations. So what is a 2D transformation? After an object creation, so first you created the object. So after the object creation, sometimes it may requires to change the object in a position or in size. That changing you call it as a transformation. Transformation is nothing but it's a changing of an object after creation. Changing of an object after creation in terms of position or in size. In terms of position or even the size also. That you call it as a transformation. So the changing after object creations, it may requires to change the object in position or in terms of the size. So that changing you call it as a transformation. There are different types of transformations are there. Let me write that. Different types of transformation. So what are the different types of transformations that are present in the way of 2D or 3D, whatever it may be? So the same concept, but only the coordinates will be the different for the 2-dimensional and the 3-dimensional. So the different types of transformations are translation, scaling, rotation, rotating, and reflection and shearing. So these are all the different types of transformation. So let me explain you each and every transformation, that is a 2D transformation, by taking the examples. So first let's start with the translation. So what is these translations? How you are going to change that object in terms of the position or in terms of the size. Let me take the first one, that is a translation. So translation. A translation means it will shift the object from one position to other position with the given translating factors in x-axis or y-axis. So translation is nothing but it will shift the object, whatever the object that is given. So in terms of x and y axis, it will shift the object from one position to other position with the given translating factors in x or y axis. So to translate a point from coordinates, let us take to translate a point from coordinate position. So what are the coordinate positions? Let us take x and y. X and y coordination position to another, that is, let's take x1, y1. We add algebraically the translation distance. The translation distance like tx and ty to original coordinates. So that is the concept. Translation is nothing but shifting the object from one position to another position. So let's take one position is xy and another position is x1, y1. So I want to change the xy object to the x1, y1. So how can I change? I simply adding the algebraic translation distance tx and ty to the original coordinates. So whenever I add tx, ty to the original coordinates, I'll get a translated image. So let me write it in terms of line. So what are the new coordinates? That is the x1. I want to change that object to the x1. So x1, how I will get this x1? Simply adding the original coordinates to tx. So tx, ty is here, it is tx, and ty is called shifting factors. Shift vectors. because I want to shift the object. If you want to shift the object, you need to add those shift objects to the original coordinates, then the object will be shifted. So the new coordinate is equal to original coordinate plus shift x. In the same way for y-axis, the original y-axis y coordinate will get as the original coordinate of y plus t1. So just remember this. Simply add tx distance to the translation distance to the original coordinate and ty the translation distance to the y coordinate. So the formula will be like this. X dash, y dash, I am writing in terms of matrix. xy is the real coordinates. I am just adding dx, dy. So here dx and dy are the translation distance. Okay, the translation distance. So let's take this as a graph. So here this is a p x comma y, and I want p x dash x1 x dash or y dash or x1 or y1, and here this is dx, and the difference here it is the dy. So you can write it formula as p dash is equal to p plus t. So here t is nothing but the translating factor, and the dx and dy are along x-axis and along y-axis. So let me explain this translation transformation by taking one example, so that you will clearly understand what exactly the translation is. Let's take one triangle is given with a vertex as ABC, having the coordinates. Having the coordinates A as 2, 2, and B as 10, 2, and C as 5, 5. So one triangle is given with a vertex as like this, and translate the triangle. Translate the triangle with, so they are giving the shifting vectors, that is a dx is equal to 5 and dy is equal to 6. So this is a problem. They are given one triangle with a vertex ABC, means here this is a triangle with vertex ABC. ABC. A has a coordinates 2, 2. So in the x-axis 2 and the y-axis 2. And here it is like 10, 2. 10, 2. And C as 5, 5. So these are the original coordinates. Now I want to translate this image. So either in the shape or in this position. Okay. So now let's start the problem. So what's the formula? Let me take formula is p dash is equal to p plus t, right? Let me take the fresh paper. So first in terms of a, you need to be calculated. So a dash is equal to a plus t. So what are the a coordinates here? xy 2, 2. Let me write a is 2, 2, and b is 10, 2, and c is 5, 5. Okay. And t, what are they given? Dx and dy, they are given it as 5 and 6. Now add. What you will get? 7, 8. So what are the new coordinates of a dash? A dash is 7. A dash is good 7, 8. In the same way, b dash is equal to b plus t. So what are the b coordinates? 10, 2, and dx and dy 5, 6. You will get the coordinates as 15, 8. So b dash is equal to 15, 8. These are the new coordinates. And c dash is equal to c plus t. Okay, what are the c coordinates? 5, 5, x, y, and dx, dy 5, 6. Okay, so you will get the new coordinates are 10, 11. So c dash is equal to 10, 11. Now take the original picture. So let me take 2, 4, 6, 8, 10, 12, 14, 16, like that. And here also 2, 4, 6, 8, 10, 12, 14, 16. Okay. So first a dash 7, 8. So 7, 8. Where is the 7? 7 here in the x-axis and 8 is here. Okay, and B 15, 8. So here 15 and 8 is here. And in C 10, 11. So this is a 10 and the 11 is somewhere is here. See. So see the previous one, the original one here it is below this line, means the coordinates are 2, 2. But here the coordinates of A is 7, 8. Means it is increased, means the picture is going upwards. Here the picture travels upwards. Okay, means the direction is changed from it is translated. The image is translated to upwards. So from here to the, means in this position to the above position. So just translated the picture. So this is about the translation. I hope you understand. Thank you. Students, welcome back. Now coming to the 3D transformations in the computer graphics. So far you have seen about the 2D transformations. Now let's see the 3D transformations. So just like 2D, the 3D is also having different types of transformations. So the different types of transformations are so what are the different types of transformations? Translation, scaling, rotation, reflection, and sharing. So just like a 2D, the 3D is also having these different types of transformation. So here also we will just discuss what is a translation in terms of 3D, scaling, rotation, reflection, sharing in 3D transformation. So let us take one by one. The first one is the 3D transformation of translation. Let me take, it's a 3D translation. So in 3D translation, the translating factor will be, what are the translating factors? The translating factors are dx, dy, dz along x, y and z axis. Along x, y and z axis. So whereas in 2D transformation, you are having only dx and dy along x and y axis. But here in the 3D translation, the translating factors are dx, dy, dz. Okay, so here I am directly representing this translation with a homogeneous form. We can represent in the homogeneous form like, so how can you represent? The P dash is equal to, that is x dash y dash 1, because I am using the homogeneous coordinates, so that's why I have kept z dash and y. This is the 3D. So if it is a 2D, you just take x dash, y dash and 1. But if it is 3D translation, so you have to take x, y, z coordinates. Okay, and 1 is a homogeneous factor, is equal to 1, 0, 0 dx, 0, 1, 0 dy, 0, 0, 1 dz, 0, 0, 0, 1 into x, y, z, 1. So just like a 2D translation, only the difference here is you are adding one more extra coordinate, that is a z, and one more translating factor, that is a dz. That is the only difference. And this is a matrix, is a triplet matrix you are taking, 4 by 4 matrix you are taking. Okay, so let me take one simple example to explain this 3D translation. Let me take the example. A point has a coordinates x, y, z. X, y, z coordinates are there. A point has x, y, z coordinates, that is 5, 6, 7. In the direction x, y, z direction, let's take 5, 6, 7. The translation is done in x direction by 3 coordinates and y direction in 3 coordinates and in z direction by 2 coordinates. Shift the objects, okay, and find the objects of the new position. So that is a question. The thing is, let's see. The coordinates of the points are coordinates of point or 5, 6, 7. So these are the coordinates of the points. So let us take. Now the translation vector in x direction. Let us take translation vector in x direction. Let us take the translation vector in x direction. Okay, that is tx is equal to 3 and ty is equal to 3 and the tz is equal to 2. They are given in the question. Okay, so they are given in the question that the translation vector in x direction, that is tx is 3, and in y direction ty is 3, and in z direction tz is equal to 2. Now the translation matrix. Let me write the translation matrix. So if you got the matrix, you can directly apply the formula. 1, 0, 0. So this is a formula tx, 0, 1, 0, ty, 0, 0, 1, tz, and 0, 0, 0, 1. So this is a translation matrix. Here you need to substitute the values of tx, ty, dz. Now multiply coordinates of the point with the translation matrix. That is a p dash is equal to t into p. This is a formula. Okay, substitute the values here and calculate. X dash, y dash, z dash 1 is equal to, what are the coordinates of the point that are given? 5, 6, 7, 1 into the translation matrix, that is 1, 0, 0, and tx is 3, 0, 1, 0, ty is 3, and 0, 0, 1, tz is 2, 0, 0, 1. So the new coordinates are 8, 9, 9, 1. Okay, so now x dash is equal to 8, y dash is equal to 9, z dash is equal to 9. So these are the new coordinates. So this is how you have to be calculated. Thank you.